Hello guys, this is the first video about finally the backward solve. Let's put that down. Backward solve. And what is it? So far we experimented with, I spoke about backward solve in the very first video, and then I think I never spoke about it again. I think now it's time, now that we've built a bit of knowledge about control rig, I think it's time to talk about the backward solve. So far we have been seeing the setup event, the forward solve, and the third one finally is the backward solve. So what is it? Now, we know that the setup event is kind of a init of a Python class where you initialize the variables or initialize the control positions or initialize whatever value you want. We saw that many times. Or is, if you want, kind of the construction script in a blueprint. All right? It's not necessarily the same exact thing, but conceptually is the same. It runs once and it runs before the rig gets evaluated. So that's where you can store and initialize values. The forward solve, let's talk about the forward solve. You have a bunch of controls, and these controls are rigged, hooked together, parented together, and the manipulation of these controls, if there is if they are Euler transforms or Booleans, we saw them, manipulates a series of nodes, a series of solvers that computes math and outputs data, and the data drives the skeleton. So I want you to see this arrow, okay? So the controls in the end, through a network, do drive the skeleton, and also the skeleton drives the geometry via skin cluster. We haven't seen that yet, but through the manipulation of these values on the controls, you can also drive morph targets or blend shapes. Blend shapes is the Maya word, morph targets is the Unreal Engine word. It's the same thing. It's a linear deformer. It interpolates between shapes. We're not going to see that today. But so you can see that controls, rigGraph, IK, FK, blah blah, twist, whatever, drives the skeleton. So the backward solve, it's pretty much the opposite. Backward solve. So if the forward solve goes from controls to bones, the backward solve takes a skeleton as an input, and through a series of nodes or rig logic, it drives controls. Okay. Now, why do you want that? Now, if it's a static skeleton, this makes absolutely no sense. But the input of a skeleton can be many things. It can be a motion capture anim. It can be a simple animation sequence in Unreal that you found somewhere. It can become keyframed animation coming from a DCC, from Maya, Blender, from a Maya rig, from a Blender rig, whatever you can think of. Okay, so basically, in the end, all of this stuff here, in Unreal becomes an animation clip or animation sequence. Sorry, I think the proper node name is animation sequence. The animation sequence, it's a node that is associated with a skeleton, and it contains animation data on bones and morph targets. So you have your skeleton, that is your skeleton, and then you have the skeleton animation. Okay, and this animation gets applied to the main skeleton through an anim sequence. If you're familiar with Unreal standard way, this is very, very basic stuff. Now, the power of the backward solve is that allows you to take motion capture animation, animation in Unreal, procedural animation, whatever you can represent as an animation sequence, and transform this animation that is basically values on bones onto controls animation. So instead of moving the bones of the skeleton, you're moving the controls. Okay, so let's design it this way. You're moving the controls, and this is really powerful because this what allows you to do is to ingest motion capture data, and then instead of going back to a DCC application to clean that up, apply that to a rig, to an inverse rig, and then clean that up again, you can do everything in engine, meaning that you can take motion capture data and change the animation using the control rig, which is much easier. So let's have a look now in Maya and then Unreal. So in Maya, I prepared the scene, and it's a very simple scene. This scene, it's a bunch of objects, and these objects are each object is basically skinned to a bone, which I conveniently called sphere bone, cube bone, cylinder bone, cone, and torus. And then they are sitting all under the root, a root bone. Then I exported this as a skeletal mesh, and this is the same exact skeletal mesh with the same exact tree of skeleton tree. And then in Maya, I've animated. The sphere goes simply up and down. The cube goes up and down, but a bit less. The cylinder goes up, but rotates 90 degrees. The cube goes up, but rotates 180 degrees. And the torus scales. Okay. So in here, if you see this Maya scene, it's basically just a geometry and a series of bones animated. What I'm trying to mimic here is basically not having a rig at all in Maya. I'm rather having something that can come from mocap. Now, I know that this doesn't look like a human being, the classic mocap puppet, but this is the same thing. I'm just using this because it's a simple example. Later on, we're going to move and implement backward solving in our modules, the modules that we saw for Skeleton, for example. So this animation here is pure raw animation data on joints. Okay, I exported this animation, and this animation became this animation, and it's amazing. It's the best character you ever saw. There's nothing like it online. So you have objects moving up, objects rotating more, and objects scaling, and then a big root motion. Okay. So if I were to drag this in the scene, I can simply apply this animation in the standard Unreal way, and this would play. All right. If I go here and simulate, this will play, and that's that. But what happens what happens if this is a character and the mocap, it's a bit, and it requires to be clean. There are some interpenetration with the arms. The normal way would be to go back to a DCC application or clean that in a motion capture application such as Mobo, Motion Builder, or go back to your original source and redo a shoot, Or maybe this animation, the skeleton data comes from a Maya rig, a baked down Maya rig, and then you have to go back to Maya and clean it up there. What if instead, once we have this animation, we can take this animation, but rather than having it on bones, we have it on controls. So then we can animate directly in Unreal. Well, that's what backward solve is for, hence the backward. So let's have a look at the graph. At the very beginning, let's talk about these two items first. So this is a very simple graph, and I left it that way on purpose because it's the first video about backward solving. These items are, these two nodes are simply collections of bones, and basically this first one is it's basically this one. It's all of these bones, drag and drop that, create collection. Now these two nodes are the same, so they are the same and in this order. Okay, the order is important. The second node is the same exact thing but with controls. Now what are these controls? Is because I just in this example, to keep things simple, I renamed the control exactly like the bone. So we have root, sphere, cube, cylinder, cone, torus. Okay, so what I've done is I took these controls in this order, drag and drop them, and create collection. Okay, so this is what it is. In the setup event, this should not be a new thing for you. I'm looping through all the bones. I'm taking the corresponding bone, I'm taking the corresponding control, and I'm getting the transform of the bone. I'm setting the control offset. This automatically places these objects in the right, at the same position of the joint. Okay, so this is simply snapping the controls, the control offset actually, at the same position of the joint and nothing else. This is just a compacted way to do through looping. Okay, so the forward solve. So I want you to have a look a little bit. There is a little bit of symmetry here, and the symmetry is important for when you try to understand and debug things. So let me try to do it this way. Maybe I should have cleaned this up sooner, before I started the video. So let me put this thing here. There it is. So in the setup event, because I'm placing the controls and I want these controls to be at 0 but at the position of the bone, and we saw this many times, I'm using the set control offset. So I'm getting the transform of the bone and I'm using this transform to set the offset of the control. In the forward solve, it's very similar, it's the same loop, but I'm getting the transform of the bone. Sorry, I'm getting the transform of the controls. I don't know why it says bone here. These are the controls. It doesn't matter, but this, just so you know, this is not a bone. This is a transfer. It's a control. So in the second list, I'm looping through that. I'm getting the first item. I'm getting the transform, and then I'm getting the same item but as a bone, and I'm setting the transform of the bone. So this is a get transform control to bone. What this does, it connects the sphere to the sphere geometry, actually to the sphere bone. So this sphere is connected to that. The bone is moving it 100% like the sphere. Okay. So in here, I want you to keep in mind this. These are my 3 events: setup, forward, and backward. In here, the bone drives the control offset. In the forward solve, the control drives the bone. The control transform drives the bone. In here, the bone drives the control offset. In the backward solve, you basically want to implement the same exact thing we did in the IK FK module when we did follow mode. Basically, in here, the bone drives the control. This is a set transform control. So this graph here is the same, identical to this graph here. The only difference is that in the backward solve, I don't want to use the control, set the control offset. I want to set the value on the control itself. Ignore the fact that it says bone here. Okay, so that's why I'm saying there's symmetry. I'm gonna say that once again. I'm sorry. Repetita juvent. So in the setup, the bone defines the position of the offset of the control, so the controls are at 0. In the forward solved, the control drives the position of the bone, so this is your standard manipulation, is everything we have been doing so far. The fact that the cube moves, it's because the cube control moves the joint, the cube bone, which is attached to the cube geometry. In the backward solve, it's the bone that drives the control, not the control offset, the control itself, which means when I move the bone, right, when I move, for example, the cube bone here, when I move it, is the controls that is following. It's the same exact thing we did in the IKFK module. Okay, so what this allows us to do is this. So let me get rid of that. Let's start from scratch. Empty scene, empty animation sequence. Let me not save that. This is my animation sequence, and what you can do is, let's drag this into the scene. Let's place it here. This is just a skeletal mesh. It's not the control rig. In here, I dragged and dropped the skeletal mesh into my sequencer, and in my sequencer, I'm gonna apply the only animation I can find, which is this one. So now in here, this is a standard Unreal workflow, right? So I have a skeletal mesh, I have an animation baked data on joints, and I'm applying that animation on the joints. Okay, but what if something here, we're not happy with it because this is dirty mocap data, or this is bad animation from the CC application. There is some problem. Instead of going back, pausing the production, going back to a DCC, calling the guy who did it, what if we can change this on the fly? Well, because in this control rig, remember that this node is aware of these nodes because it's where it's coming from, which means because we have implemented the backward solve, because in this graph this node exists and is connected, what you can do now in here is right click on the skeletal mesh and say bake to control rig. This wouldn't be available otherwise. I'm selecting which control rig. This node here is this one. If this is on for you guys, turn it off, because I want 100% the animation. This will try to simplify the curves, but in this case I don't care. It will take 100% of the curves. So what happened, you can see that a new track has been added, which is the track for the control rig. So this became effectively a control rig. But now the animation is not on the bones. The animation that is on the bones has been deactivated. It's muted. You see it's gray? So this animation is not happening because of the track we put before, but rather it's happening because the controls are now animated. Why are they animated? Is because when we click that button, when we clicked this button here, it run this procedure. It says per frame, take the animation of the joint and apply the rule related to that joint to something. In my case, because in this simple example, my joints are exactly on top of on top of the controls, the animation is 100% identical. With the difference that now, if I'm not happy about I don't know here, I can use layering, the standard layering system, and I can start moving things around. Now, this procedure, the baking, allow me to convert joint animation data into into control rig. Now I'm free to use the forward solving. The fact that now I'm moving the control and the geometry is following is because this is a standard manipulation way of control rig. So in this case, when I'm doing in the viewport, is using the forward solve. All right. So this is pretty much the gist of it when it comes to backward solving. It's really powerful. This is something that in the industry would have taken, you know, a little bit longer, because for every rig you have to build something that is an invert rig, and it's a bit more it's a long process rather than having one click that does it for you. As long as you implement a rule that makes sense for the rig to move in the same way, then you're good to go. On top of that, you have a way here to check the backward solve, to check that the animation is correct. Where is it? The animation. Yeah, let me use the specific animation. You can see that, you know, in the backward solve, what you're trying to achieve is seeing that everything still works. You know, so this is what you wanna try to do when you're debugging. So in here you can see that it's cycling between backward solve and forward solve to see that the full animation works. So it does this process. It runs this, instead of baking down, it runs this graph by using an animation as an input. So this is how you would debug live. Okay, if your animation in here matches 100% the animation that you would get in the forward solve, not in the forward solve, in the backward solve. Where was it? Yeah, there it is. This one, sorry, I meant this one. I got confused by this naming. So if the two animation, the one from the joints and the one from the controls, do match, then you're good to go. It means that your logic that you have implemented here works. Okay, this is it for this video. Thank you.